This is our first video in the electricity unit for grade 9. So we're starting off by talking about electrostatics, which is static electricity. And then later on in the unit, once we're done with this, we're actually going to talk about current electricity and look at circuits and things like that. So let's go through our introduction to electrostatics. So you have some blanks to fill in on your notes. I'll give you some time to fill them in, and then we'll talk about them. So, the study of static charges is called electrostatics. And electrical charges are subatomic particles that exert an electric force on each other, and they're very, very small. These electrical charges are very small. So now that you've copied those down, let's just review some of the particles that we know exist in atoms. So we know, we know the three subatomic particles are protons, neutrons, and electrons. So we'll write those in: protons, neutrons, and electrons. And hopefully you remember that what the charge on each one of is. So the charge on protons is positive. There's no charge on a neutron, it's neutral. The charge on electrons is -1. And remember that protons and neutrons both exist in the nucleus. And because of that, because they're stuck in the nucleus, they can't actually move around. The electrons are outside the nucleus, and they're in those rings or energy levels outside the nucleus. And in the last unit, we talked a little bit about how electrons can move from one atom to another and create an ionic bond. That same thing will happen in this unit when you talk about electricity. So electricity is really all about the movement of electrons that are outside of the nucleus. So an object that has more electrons than protons is negatively charged. So if we check out this example here, here is an object. If you count all the positive, the pluses, there are 6 of them. If you count all the negatives, the little minuses, there are 9 of them. So when we add them up, 6 plus -9, we get -3. So the net charge on this is -3, and it's negatively charged. It has more electrons than protons, or more negative charges than positive charges. An object that has more protons than electrons is positively charged for the exact same reason. So here's an example here. If you count all the positive charges in this circle, there are 8 of them. And there are 6 little negative lines. So when we add those two up, we get +2, making this object positively charged. So how do we charge objects? Well, objects can become charged when electrons move from one object to another. Here's the thing you have to remember. Protons never move. Remember, they're stuck in the nucleus with the neutrons. They don't move. And electrons that are floating around the nucleus can move from one atom to another. The electric charge that builds up on the surface of an object is called a static charge or static electricity. And the charges are called static. Static basically means that they cannot move, so they remain in one location until they're given an escape path. So we're going to talk about what that means a little bit later on. So big thing you have to remember, only electrons are ever going to move. We're going to draw a lot of examples, a lot of diagrams. Only electrons can move. Protons never move. So, law of electric charges. You need to know these. So put a star beside this. You might have to do some memory work on here. So the law of attraction states that particles with unlike charges, so like a positive and negative, they're unlike, they will attract. So if you have opposite charges or unlike charges, they attract together. If you want to fill in that blank and draw in a little picture to represent 2 opposite charges coming together, kind of like a magnet, they're going to attract together. The law of repulsion says that particles with like charges will repel. So if you have 2 positive charges, they're going to push away from each other. If you have 2 negative charges, they're going to push away from each other. So you can see that with the arrows that I drew. So if you want to take a minute and make sure you have those diagrams copied in and you understand them, and then we'll move on. So Like charges repel, and unlike charges will attract together. How do we measure electric charge? This cool guy, Charles Augustin de Coulomb, worked with electric charges and basically discovered these laws of attraction and repulsion. So in his honor, the electric charge is measured in coulombs. The symbol for that is C. Now here's a really cool thing. 1 coulomb of charge is 6.24 times 10 to the 18 electrons. When you have times 10 to the 18, that means there are 18 decimal places after the 6. So if you check that out, that's a lot of electrons. 62400000000, tons of electrons in 1 coulomb of charge. So there's sort of a tidbit of information for you. We're going to come back to using coulombs a little bit later on. All right, last little topic for today, electrical insulators and conductors. We've looked at conductivity before when we looked at physical and chemical changes, and you guys tested the conductivity of some substances. So conductivity now, you know, is the ability of materials to allow electrons to move freely in them from atom to atom. So if something will conduct electricity, it means the electrons can flow through them. If something cannot conduct electricity, it means that the electrons cannot flow through it. So I have a video to show you. I think what I'll do, just because it's a little bit long, I'm going to show it to you in class. So we'll save that for class. All right, electrical insulators now is a substance in which electrons cannot move freely from atom to atom. So as a result, a strong charge can build up on an insulator. Some examples of really common insulators: wood, glass, paint, wax, rubber, plastic, and pure water can all be insulators. They will not let electric charge flow through them. Electrical conductors, we already know, it'll be a substance where electrons can move freely from atom to atom. And because the electrons move, the conductor, will not build up a static charge. And I'll give you a second to copy down some examples of common conductors. Most of them are metals. Copper and gold are really common ones. That's why most wiring is made out of copper. Gold is an awesome conductor of electricity as well, but gold's really expensive. So if we tried to wire our entire house with gold wires, that would cost a lot of money. So that's why we use copper wires a lot. Then there's silver, iron, aluminum, nickel, and water with dissolved minerals will also dissolve electricity. And the human body is also a fair conductor of electricity. That's why you can get shocked if you touch a plug or if you get in the way of an electric circuit. All right, so take a look at this and see if you can label the images below as an insulator or a conductor and explain why. So in the first one, you can see the protons aren't moving around, but you can see arrows coming off of those little blue electrons. That means that those little blue electrons are moving, and if something can move, what is that? Oops, sorry. If something can move, so here, you have to see the electrons are moving. So your definition of a substance where electrons can move through is a conductor. Reasoning, again, your electrons can move freely through the material. Now, take a look at the second example. In this case, we've got positive and negative charges, and they're kind of stuck together. There's no arrows, so nothing's really moving around. So we call this one an insulator. And again, the reasoning, the electrons cannot move. All right, so that's basically our introduction to electrostatics. We're going to look in the next video at how to actually create an electric charge. But for today, that's all you need to know. So we'll watch the video in class and go through some more handouts and examples.